Hi, in this video, we are going to talk about skewness and standard deviation. So to start off with the skewness, I'm just going to go over what the worksheet says, but then I'm going to show you a picture, and I'm not going to try to draw it because that is not going to work out well. You'll see once you see the picture. But it says data is said to be skewed if there's a large concentration of small values with several other much larger values. And it's a representation of how balanced the data are. So let me switch screens real quick and show you some pictures. So here are some histograms, and we have the frequency on the left and the data values on the right. And this first picture, it says skewed to the left. And so this, I think I can write on this with the zoom features, skewed to the left. And so you'll notice here we have a picture, and it kind of goes up. It does eventually come down, but overall it's not this, oh gosh, I'm just drawing everything. It's not a bell-shaped curve. It's definitely lopsided, whereas skewed to the right is also lopsided, but it's like lopsided the other direction. So on the skewed left, we have the tall towers, these guys over here, these tall ones with the most frequencies. Those are on the right, and you can see that it kind of trails off as we go to the left. We get smaller and smaller numbers of the smaller and smaller data values. So there's like one for in this box, and there's one in this box. But then when we get over here, there's like 10 and then 20, and it's getting bigger and bigger as we go to the right. So this is called skewed to the left because the tail goes to the left. This other picture is the exact opposite of everything I said. These smaller values like 1, 2, 3, they have the tallest towers. They have the highest frequency. And then as we go to the right, it's smaller and smaller, less frequent. Even though the data values are bigger, the frequency is smaller. And so whichever way the tail goes, whichever way it stretches out, that's the way it's skewed. This one stretches out to the left, so that one's skewed left. This one stretches out to the right, so that one's skewed right. But I always get these backwards. And so a very easy way to remember which is which is to just like take off your shoes, take off your socks, put your foot right there on the paper. And when you look at this skewed left, this is like your left foot, because don't laugh at my drawing. We have little toes and then a big toe, right? There's the tall tower. That's your big toe. And then as you go to the left, your toes get tinier and tinier and tinier. When it's skewed right, it looks like your right foot, because we start off on the inside with your big toe, and then as you go out, your toes get tinier and tinier, just like this skewed right. So skewed left is your left foot, skewed right is your right foot. So that's how you can tell just by looking at the pictures which direction it is skewed. Okay, so I'm going to try to clear all these drawings. Oh, I see my, does that work? Okay, whatever. I'm just going to switch and hope that they disappear. Okay, so we're going to go back to our notes. And when you have a picture, that's a great way of talking about it. So we have skew to the left versus skew to the right as our two scenarios. Now, if you don't have a picture and you're just given the mean and the median, well, we look at where the mean is compared to the median. So I'm going to rewrite this just slightly. This says if the mean is smaller than the median, if the mean is on the left, it's skewed left. This one, I'm just going to change the way it's written. I'm going to say the median is less than the mean. It's the same thing. The big alligator is eating the mean in both scenarios. I just flip-flopped everything. And so in this example, the mean being on the right means that it's skewed to the right. And so whatever side the mean is on, that's which way it's skewed, because those outliers, or even those extreme values, even if they're not outliers, the smaller values or the smaller frequencies, I mean, those will affect the mean. So the more small values you have, the lower the mean will be. The more big values you have, the higher the mean will be. And finally, it's symmetrical if the mean equals the median. I can draw this one. Symmetrical is where all of your frequencies, all your bars of your histogram are basically the same. I did some a little taller, some a little shorter, but overall they're basically the same. So that would be symmetrical. Okay, so looking at looking at these three right here, it says a data set of the score in a class of elementary statistics at a junior college has a mean of 78 and a median of 69. So what I like to do first is write them in number order. 69 is the median, that's smaller, and 78 is the mean. So now, because they're in number order, I can see that the mean is on the right. So with regards to the shape, this is skewed right. Let's say right. Now it says night. Okay, well, you know what I'm trying to say. That clearly doesn't say left. So it's supposed to say right. Oh gosh, I'll just print it. R-I-G-H. Okay, the next one, again, we just write the numbers in number order. We see which side the mean is on, and that's how it's skewed. So 44 is less than 46. 44 is the mean. 46 is the median. Mean is on the left, so the likely distribution is that it is skewed left. And that's it. You just write them in number order, see which side the mean is on, and that's which way it's skewed. On the last one, the mean and the median are the same. They're both equal. So that's the special one that I was drawing right there. That one's symmetrical. So you can see when they're equal to each other, it's symmetrical. So for the last example, because the mean equals the median, the shape is symmetrical. Okay, that's everything about skew that we need to talk about. It comes up, but it's not very deep. It's just those basic ideas right there. And that's about as deep as we're going to get into it. So now we're going to talk about the standard deviation. And we are not going to focus too much on the formula. We will do it once. It's painful. You kind of got to see how painful it is. And then you can see why we never want to do it again. So the standard deviation is a measure of dispersion of the data from the mean. What that's saying is, if we have a number line, where am I going to draw it? I'll draw it up here. If we have a number line, and the mean is going to be somewhere in the middle of the number line, and we have our standard deviation, or we have our data. These are dot plots. Less and less as we go out. So how far is it from the lowest to the highest? What's that range right there? That's what's contributing to the standard deviation, how far away it is from the mean. It's not literally exactly just a straight measurement. There is a little calculations to it, but that's what it's talking about. How far is the data dispersed from the mean? And the importance of that we will get to as we go on. Okay, so similar to the standard deviation is the variance. The variance is another way to measure this. In fact, their relationship is that the variance is equal to the standard deviation squared. Now, standard deviation has two symbols. It can either be sigma, which is the population standard deviation, or it will be S, which is the sample standard deviation. And it's going to matter which one we use. We'll talk about that in various problems today. But the variance is the standard deviation squared. So we could say that variance equals sigma squared, or variance equals S squared, depending on if we're talking about, and I'll put this underneath, the population or the sample. Okay, important rules about standard deviation. One, standard deviation is always positive. And I'm going to show you when we do the first example why that has to be. The standard deviation could be 0 if all data values are equal. And then from there, it's just, if everything's equal, if everything's lined up in the middle, that's the standard deviation is 0. The more spread out the data gets, the bigger the standard deviation is. So it's either going to be all lined up in the middle, or it's going to be spread out bigger, bigger, bigger. So it's either going to be 0 or spread out to be positive. Standard deviation has the units of the original data, and standard deviation can be influenced by outliers, just like the mean can be influenced by outliers. Pretty much the only thing that can't be influenced by outliers that we've talked about is the median. There's other things, but just based off of what we've talked about, it would be the median. Okay, so this is the official formula. I'm gonna go through it step by step. You don't need to memorize this formula. In fact, I prefer that you don't even use this formula because it's such a pain. So much easier just use your calculator. But I do want to talk about the formula so you can see why sigma and S are different. So remember, sigma is for the population and S is for the sample. And the difference between these two is you're going to divide by n for the population or n minus 1 for the sample. So it says that right here in step 4. Divide by n for the population, divide by n minus 1 for the sample. Again, you don't need to have this memorized or even really use it. However, because of those two differences in the formula, that means sigma or S are going to be different answers depending, and you're going to have to choose which one is the right one for the problem. So let's just jump right into standard deviation and we'll kind of work out the kinks as they come up. So for starters, and this is very, very much a calculator problem, we're going to compute the standard deviation. So I have a little table here so we could do it in organized steps. So first we have our numbers, and they do not need to be in number order. You can just write them down in the order that they're given, or you could write them in number order, but that only the median actually requires it. And so what we're going to do here is we're going to do our X value minus the mean. So that means we need to calculate the mean. So you get out your calculator and you go to your lists and you're going to type in to your L1. We've done mean before. So you're going to type into your L1 the 22, 30, 25, 19, 17, and 15. So we have all of that hanging out. Oops, let me switch my video. All of that hanging out in L1. And once we have that, then we are going to get out of here, quit this screen right here, and then go back to stat on this calculator and calculate one variable stats. Anyone out there, no matter which calculator you're using, we have the L1 is our list, and then our frequency should be nothing. And then we will calculate this. And so our mean is 21.3 for this problem. And just to kind of make sure everyone, no matter which calculator you're using, is getting these same answers, we're just going to do this again. So we have our list 22, 30, 25, 19, 17, 15. We're going to hit get out of here, then we're going to hit stat, one variable statistics. I was not doing a frequency table last time, so double check. You should be L1 and then 1, calculate, and again you can see 21.3 is the mean for this problem. So going back to our page, oops, and I can show my face again. I don't need the calculator there still. We have, okay, goodness gracious. 21.3 is our mean. And so for all of these, we're going to do the number minus 21.3. And we're just going to do that for all of these. 19 minus 21.3, 17 minus 21.3, and 15 minus 21.3. So I'm just going to throw that in the calculator. And once you get the subtraction, then you're just going to square it. So what I'm going to do here is I'm going to put my 22 minus 21.3, which is 0.7. And then I'm just going to square it since I'm right here. So if you haven't squared before, it has its own button right here next to the 7. And when I type in squared, it's going, if I just hit the squared button, it's going to take that previous answer and square it for me. And so this time it gave me a, I don't know why it just decided that I wanted fractions, but remember I can just switch back using this wiggle button next to the 3, and I get 0.49 as my squared. I'm going to do that. I'm actually going to do this one real quick. Oh wait, you can't see what I'm doing. I'm going to do the 19 real quick. The 19 minus 21.3, just because, well, I'll show you why when we do it. Okay, so I'm going to do, I'll do it on this calculator. So we have 19 minus 21.3, and I get negative 2.3. That's fine. There's no problem with that. And then I want to square it on this calculator. The square button is kind of kitty corner from the 7. It's right up here by the comma. So I'm going to hit squared. And notice it says answer squared. And the reason I'm bringing this up is because this problem, it's a negative number, and I want to square that negative number. And by typing in the previous answer squared, it's going to square the negative for me and get a positive number. If you just type this in by hand, negative 2.3 squared, you're going to get the wrong answer here because it's there's an issue with the order of operations in the negative. So that's why I like to use that answer button to just shoot over to the correct answer right away. It'll take care of putting parentheses around it to get that negative. And all you have to do is just keep typing things into your calculator. And then I guess we could write them down as well. Okay, so that was 5.29. So I'm just going to keep doing this. I'm not going to show my calculator every time, but I did 30 minus 21.3, and that got 8.7. Square it, just do it all over here and get 75.69. 25 minus 21.3 is 3.7. Square it and get 13.69. This is a pain. Do you see why I said we wanted to do a shortcut? This is terrible. All right. 17 minus 21.3 is a negative 4.3. When I square it, I get a positive 18.49. And then finally, 15 minus 21.3 is negative 6.3. And then I square it and I get 39.69. Okay. Yay, that was fun. So then it says add the square deviation. So I'm going to add this whole column and I'm going to put my answer right here. So I'm just going to type these all in. It's going to take a minute. 0.49, 75.69, 13.69, 5.29. I'm adding this up. 18.49, and last but not least 39.69, and I get 153.34. That's terrible. Okay, that is almost the answer. That is just adding everything up. The last step we're following this up here. So we subtracted, we squared, we added. We have 2 more steps. We're going to divide by n, and then we're going to take the square root. So in this problem, there were 6 data values. So we are going to do 153.34 over 6. That's going to equal our sigma squared. And then finally, we are going to take the square root. All right, a new function on the calculator. So I do want to talk about this. We can just do it all at once. We have, I just be bopping back and forth between calculators. They do the same things. What we want to do is we want to take the square root of that fraction. So square root on all calculators is right above the square. It's the little, in this case, the red button above the square. That's not red, that's green. The green button above the square on the graphing calculator. It's the blue button above the square key. So I'm going to type in the square root, and then I'm going to type in the fraction button, because now I'm taking the square root of that whole fraction. And the fraction we are taking the square root of is 153.34 over 6. And there is our standard deviation. 5.06. Okay. Over here, the fraction button's a little different, but I'm going to do it the same order. I hit second and then hit my square root. I feel like it's too close. Or maybe it's just too bright today. I don't know what's going on. It's hard to see. Okay. And then the fraction button is up here in F1, which is green. So I hit alpha, F1, enter. And now I can do the same thing, 153.34 over 6. And there we get the same answer. Okay, yay. So what am I doing? I'm going to switch to myself real quick just to say, that's terrible, right? Like that was literally the worst. A, you have to remember all the steps. B, you have to write down all that stuff. And C, it's just time consuming and tedious. So now that we've done it the terrible way, we're going to do it the easy way. And it's going to go really fast right now because we already put in the numbers. But if you recall, the very first step was to type everything into L1 to get the mean. Well, if we already have to type everything into L1 to get the mean, let's just use all that to get the standard deviation. So back to the calculators we go. I'm going to go, my list, I haven't done anything really. I've just been sitting here making videos. So this list right here is the same as the problem. So we don't need to change our list. We just need to go to calculate it. So I'm going to hit stat, calculate one variable stats. Same thing we've been doing. List one is exactly the same screen we were just at for the mean, but this time we're going to get the standard deviation. And you can see on this calculator, the fourth and fifth ones down say S of X, which is the sample standard deviation, or sigma of X, which is the population standard deviation. This number, this 5.05, that's the exact number we just came up with when we were calculating it. So way back here when we were calculating the mean, we could have just been like, boop, there's a standard deviation and been done with the whole problem. Let's try that one more time. Over here, we have our data. Again, our data is already typed in there. And so I can just go to stat, one variable stats, no frequency. And here, number 3 is S. But if we go down to number 4, we have our standard deviation. So standard deviation is something that is very quick and easy to get. Once you get the hang of the lists, you can just type everything in there and get the standard deviation from there. So that's what we're going to do for the rest of the section because I don't ever want to do that again. So let me share my screen again. Going to Sam and his rose bushes. Okay. So Sam has 20 rose bushes. The number of roses, the number of flowers on each bush is, and it gives a whole list. Compute the standard deviation. So for this, I want you to take a second and put everything in the list and find the standard deviation. I'm going to do the same. And then when we come back from this, then we will go over the answer, but I'll go over it kind of quick because I'm assuming that you are pausing right now in order to do this problem. And we're back. So for this problem, you type all the numbers in to your list, and then it says to compute the standard deviation. And it says he has 20 rose bushes. So I know the population is 20. So all I need to know now is this, so the first question, is this sigma or S in this problem? So the population is 20, that's all the rose bushes. So we just have to figure out, is this sample given also 20 or is it less than 20? Because if it's less than 20, then it's the sample. So we are going to jump over. So you could just count them, like that's fine, but that's time consuming. As you've seen, I like shortcuts. So looking here, I have that n equals 20. That means I typed 20 numbers into my list. So if there is 20 in the population and I have 20 in my sample, the sample and the population are the same. So this is a population problem. Since we know it's a population problem, we know that the answer is going to be 2.98. It's going to be sigma because this is a population problem. So you can double check the n after you type it in if you don't want to count them out. And then once you do that, now that we know that's population, we are going to choose sigma for our answer. So for this problem, so it's going to be this answer, since n equals 20 and 20 is the population, then that's why we're choosing the Greek letter sigma. So for this problem, sigma equals 2.98. In this example, it says the number of flowers on each bush. So I guess for flowers, we're going to say 2.98 flowers. All right. Now that we have used our calculator a few times on that, we are going to talk about, recall the variance versus the standard deviation. So going back a page, we said that variance equals standard deviation squared. It does not matter if you're talking about population or sample. Whatever the standard deviation is, we're going to square it, and that will be the variance. So going back to this problem right here, number 6, it says the amount of order received from an online company called order.com, okay, for a month has a standard deviation shown below. Compute the variance. So the variance equals the standard deviation squared. So it's going to equal 7.54 squared. Now the units for variation would be a little wonky sometimes because technically it's dollars squared. But since we don't talk that way, we just talk about dollars. We are going to have dollars for the answer, and that means we're going to round it to the nearest cent. So for the final answer, I'm getting $56.85 because we round to the nearest penny on this. I did get 56.8516 on the calculator, but I dropped the other two because that's not how we talk about money. Okay, last but not least, just some problems pertaining to the concept of standard deviation. So we are no longer computing it, we're just talking about the idea of it. So this first one is talking about basketball and the comparing points per game of two different NBA players. The average points per game, including a standard deviation, is shown below. So we have the points per game for player A, and then we have the standard deviation shown below. On average, which player is the higher scorer? So for the higher scorer, that would be more points. So that would be player B, has more points. But which one is more consistent? So more consistent means less variety. It varies less. It's not so spread out. It's very, everything's very close to the same. So this person, their average was 27. That means they might have scored anywhere between like a 21 to like 33 in that range right there. But we're not talking about a player that has like a 70-point game, and then the next day they come in and they have 0 points, and then the next game they come in and they have 2 points, and then the next game they come in they have 87 points. Like that would be all over the place. This one is, there's the smaller the standard deviation, the less variation, the less variety. So this is going to be the smaller standard deviation. So this would be player A. So higher score means more points. Consistent score means less variety or less standard deviation. Okay, so let's try that again. Similar idea, but instead of basketball players, we're going to be talking about companies, and they sell little packets of saccharin, and that's like Equal or Sweet and Low, or those, you know, like the little pink packets that you put in your iced tea or whatever. And so it says the mean and the standard deviation are listed. So we can see right here that the top is the mean and the bottom is the standard deviation, because it tells us the symbols right there for mean and standard deviation. Also, it uses S because we're talking about a sample. Doesn't really affect us in this problem because we're not calculating anything. It's just, I wanted to point it out because it is a very consistent notation. And it says, which company consistently produces extra saccharin, extra sugar in their packets? So that would be more, I'm just going to write sugar because I can't spell saccharin. More sugar. So which one is doing more sugar? That would be company A, because that 0.026 is more than the 0.00. And this guy, company B, is very close to 2. So that would be which company? That would be A. Which company fills its packets with more consistency? So more consistency means smaller standard deviation. Deviation, how much it deviates, how much it differs. So the more it differs, the bigger it is, but more consistent means the more it stays the same. So the smaller the standard deviation. In this example, we're going to go with company B because this 0.22 compared to the 0.19 is the smaller standard deviation. So more consistent is B. More too much sugar is A. And with that, we are done with all of our measures of center. Yay, chapter 2.6 is done. Okay, so if you have any questions, send me an email. Otherwise, I will see you in the next video. Bye.